So hello everyone, I'm Tamas Losonczi and I work here as an Android developer at STRV. And today I'm going to talk about SOLID, also known as the first 5 principles of object-oriented design. So let's see those. As you may know, SOLID is an acronym and it stands for 5 principles: single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principles. And the primary purpose of these principles is to help you to develop software which is easy to extend and easy to maintain. And probably these are the most important features of an app today. If you cannot add new functionality without introducing bugs, then your software just cannot evolve. And your client will lose potential business value, and it also reflects that your code was poorly designed. So let's see what can we do about this. Our very first principle says that a class should have only one interchange. And this doesn't necessarily mean that a class should have only one responsibility. This principle is context dependent, which means that you should group all the stuff together that happen to change for the same reason and separate it from the rest. And this is the main idea behind MVP or MVVM or Viper architectures. But let's see some code. So let's say we'd like to display a list of orders. And each order has an order number, a list of line items, and each line item consists of a description, a quantity, and a price. So what we do is create a recycle adapter view. We pass the items in the constructor. We pass the item layout too. We store a reference to them. In the onCreate view holder, we are inflating a view and returning a new view holder with a classic implementation with the static nested class. In the view holder, we are storing references to the views and doing the view lookup. In the onBind view holder, we are binding the data to the view, and we are doing some sort of calculations here. Of course, we could use data binding, but for this example, I wanted to ignore data binding. And this class is quite okay, but each time we make a change to the view or how we calculate the data, we have to update the adapter as well. So what we should do is extracting the binding. No, I should go with the view first. So extract the view in a separate class. We are doing the inflation here, we are storing the references to the views here, and we do the lookup here. And also we create a binder class which will only have one method, and it will bind the order to the view. We'll do the calculations here like we did before. And now the recycle adapter view looks like this. We pass the order binder, we pass the items. In the onCreate view holder, we are just returning a new view holder, and in the new view holder, we pass an order view. And in the onBind view holder, we are binding using this binder class. As we saw, the applying SRP will result in small components, and small components are easier to understand, easier to test, and easy to maintain. And there are some other benefits. For example, division of labor becomes easy, and it's crucial for launch projects. And you will have a mental clarity as a developer if you are only dealing with small components, and you can focus more on a specific task. So that was SRP, our very first principle. Let's see open-close principle, which says that software entities should be open for extension but closed for modifications. This means that you should design a class in a way that later you don't have to change it, even if a requirement changes. And that's something that's quite hard to get right at first. So what you could do is, well, this is just a tip. So in order to apply this principle, you have to identify what changes and separate it from the rest by abstraction. So let's say we would like to integrate some third-party cloud solution. It can be Firebase, or it can be Amazon Web Service, anything you want. And we have one method, save data to cloud, and also we have this typical get instance call where it returns a new instance of this API. We would like to save a calendar class, an image class. So we create some cloud persister class. It will use this cloud solution, and it will have two methods, save image, save calendar, and this API requires some sort of path to store the data. So we also extract those in a constants. So we will have an image path and a calendar path, and we will have a save image and save calendar methods, and we will call the appropriate we will call the method with the appropriate parameter. And this is quite okay again, but let's say you would like to save all kinds of data, and it will be hard to maintain if you have thousands of different classes you would like to save. So what you could do is create a persistable interface with a getPath method, and you implement a calendar and the image class to this persistable interface. As you can see, the cloud persister will be reduced to this. We will have only one method, save data. And save data, we will only have this persistable parameter that we could use to save the data to the cloud. So I move these constants into these classes. It's logically more tied to this. And I implement this persistable interface. That's all. So what are the benefits? You don't have to change code. You don't have to update your tests. And that means you cannot break the system, if you had good tests, of course. So this one is substitution principle from Barbara Liskov. I think everyone can understand that. Okay, so what this means is that subclass should behave in a way. So if you are extending a class, you should pay attention that you should make it interchangeable with the base class without any side effects. And this is the only principle when we have some sort of rules. We shouldn't throw new exceptions in the subclass. We shouldn't expect more in the subclass than what is expected in the base class. For example, it's regarding the preconditions. So for example, you extend an integer class to make a natural number class, and you shouldn't expect that some of the values won't be negative. Postconditions, we should pay attention what are the postconditions in the base class. For example, we are extending a database class, and the database, after each transaction in the base class, the database is closed. We should do so in the subclass. Invariants of the supertype must be preserved. We should keep, that's the easiest way to define this, but we can implement this in the subclass by making assertions in the methods. And we shouldn't make immutable classes to mutable, and it's very important in multi-threaded environment. And also, if we forget to do this, then we will have security issues. Well, it's possible to have security issues. What are the benefits? We will be able to replace the implementations without breaking the system. Okay, this is interface segregation, and it says that a client should not be forced to depend on interfaces that they don't use. And generally, it's a good idea to break up interfaces into smaller ones because it's easier to implement them. And as I said before, it's good to have a mental clarity. If you have small interfaces, then it's easier to see what it does. sometimes we are forced to deal with bad designed interfaces. For example, when we use some sort, for example, in the case of Android, when we are using some listener classes, and we are just only using some part of that listener class, the listener method. And if you have many small interfaces, you can still combine into more generic one by extending those. So. Let's say we have input listener interface, which will listen to on-click, on-long-click, and on-touch. And we will have a view implementation, which will do something on on-click, on-long-click, and on-touch. But we also have another view implementation, which will only do some stuff when on-touch happens. Otherwise, we are throwing an exception. And as we saw at the previous principle, it breaks it because we are throwing a new exception that it's not expected. So what can we do? I think it's quite obvious that we should break all this into separate interfaces. We will have a click listener, a long click listener, a touch listener, and also we will have a generic one. So the view implementation will be the same, but the other view implementation will only use the touch listener. The benefits, these are easy to implement, the small interfaces, and they are easy to switch. Okay, this is our last principle, which is dependency inversion. And again, this has a very generic definition. High-level modules should not depend on low-level modules, but should depend on abstractions. And abstractions should not depend on details. Details should depend on abstractions. But what this means is that if we are making sure that we are not depending on specific implementation, rather some abstraction, it's easier to switch those implementations. And this principle, dependency inversion, is not dependency injection. The two terms are related, but they do not mean the same thing. And by using dependency without abstraction, we lose the flexibility. Yeah. So let's see also an example. So we're going to reuse this some third-party cloud solution from the OCP example. Let's say we bought a license for this, and this license is not valid anymore. So we had to come up with a temporary solution to save data. We will have this image, we will have this calendar, and we will have this cloud persister. But also we have this new client code, which uses all this. So we will have a list of persistables, and there is one method, persist all data, which will save all these. So we would like to have a temporary solution, but we also want to keep around this third-party solution. So what we should do is create some generic interface to access both solutions. So we create a persister interface with the method save data. It will get a persistable as a parameter, and we will implement cloud persister this interface. And also we will have this other solution, file system persister. And as you can see, the code is totally different here. I mean, we are creating a new file, we are creating a directory, we are opening the output stream, but they still share the same interface. So the presenter class will look like this. We will have a persister as a dependency passed here. Yes, so this is dependency injection. More precisely, this is constructor injection. So we are passing the persister here, we are storing references to all these, and we have this save data. And if I want to go to the implementation, you can see there are two implementations, and I can switch those. What are the benefits? Well, the whole point of this solid principle stuff is that you can make changes to your system without any side effect. And dependency inversion is exactly the same. In the context of Android, it's generally a good practice to create some abstraction for third-party libraries, for example, some image caching solution. So let's say you would like to use Glide. Let's then create an interface as image loader. And if you would like to switch later to, I don't know, Picasso, then you can still use that interface. You don't have to update your code, only just this small part, the implementation. So we went through all the principles, and I would also like to talk about the usage of these principles. First of all, write the usage code first. So write the worst possible code you can. Don't think about any kind of principle or object-oriented design or any clean code stuff. Basically all the stuff that Lukáš was talking about. So you shouldn't pay attention. Just write the minimal amount of code that is needed to get the work done. And after that, you will see some pattern will emerge in your code. Of course, it requires some exploration. And that's the right time to apply Solid. The second thing is never force a design pattern in your code. And never start creating abstraction first. Of course, if you are experienced enough, if you have implemented a feature like 1,000 times, then you can skip this exploration step. But it's still good to have different implementations for the same problem, for same solution. No, I mean, same problem, but different solutions. But so let's say if you are trying to solve a problem by doing the abstraction first. Let's say you would like to use a design pattern, and if you use a design pattern first, if you instead of concentrating on a problem, then it will mislead other developers, and this other developer will create another abstraction on top of your abstraction, and it goes on. So it's a bad thing. So you can end up with something like this. This is not code from STRV, so basically that's all I wanted to say. And now comes the Q&A.
Sorry, I think that you have forgot to show us example of Liskov principle.
Yeah, I know what you're talking about. The thing is that I have a very poor example, and that's the reason I skipped it. But we have some concrete rules here, and I can show it to you. I couldn't come up with any better. So let's say we have a base class, and in the base class we are, for example, throwing an illegal argument exception, and we are checking some values here. And in a derived class, we are throwing an invalid parameter exception, which is a subclass of the illegal argument exception. This is a good example, and I couldn't show any bad example, sorry. Okay. I think no more questions. And thank you.